In our last session, we were discussing about the formulation of linear programming problems. Let's take one more problem to clarify the concept. As I told you earlier, the first thing we have to find out that whether the problem is related to maximization or minimization, we have to find this thing. So whenever the profit is given in the equation, then the problem is of maximization. But when cost is given, then the problem is related to minimization. So first of all, we have to find out that whether the case is of maximization or minimization. So let's read the question. So consider two types of foodstuffs. So two types of foodstuffs are F1 and F2. Assuming these foodstuffs contains vitamins V1, V2 and V3 respectively. Minimum daily requirement. Now the term here is minimum, right? So minimum means that at least we have to take this much quantity of vitamins, and the quantity can be more than this. This is the at least minimum figure. So three vitamins are 1 mg of V1, 50 mg of V2 and 10 mg of V3. Suppose foodstuff F1 contain 1 mg of this is vitamin 1, 100 mg of vitamin 2 and 10 mg of vitamin 3. Whereas the foodstuff F2 contain 1 mg of vitamin 1, 10 of 2 and 100 of 3. And the cost is given now. Now from this point that cost is given, so we can conclude that the case is of minimization. Okay. So my problem is of minimization. So I will write minimize Z. And the cost of 1 unit of F1 is 1 rupee and F2 is 1.5 rupee. So we must consider here that two foodstuffs, that is F1 and F2, right? So the cost is given for foodstuffs. So this is 1 for F1 and 1.5 for F2, right? So this will be the equation. So if I assume or suppose F1 as X and F2 as Y. So my minimize equation is minimize Z is 1x plus 1.5 y. So this is my first thing, but it is subject to constraints. Some constraints are there in order to achieve this objective. And how to formulate the constraints? So what we will do, we will write F1 here and F2 here. This is my X and this is my Y. So I have V1, V2 and V3. Now I will make the matrix, right? So as it is given in first equation, first statement, that food's minimum daily requirement for 3 vitamins is 1 mg for V1. So the minimum is 1 for V1, 50 for V2, so V2 is 50, and 10 for V3. So I will write here 10. And foodstuff F1 contains 1 mg of F1. So 100 mg of vitamin 2 and 10 mg for vitamin 3. And this stuff 2 contains 1 for V1, 10 here and 100 here. Now I will formulate the equations with the help of this matrix. What I will get? I will get x plus y. This is 1x plus 1y, means 1x plus 1y, and at least is there. So minimum requirement, it means that we can take greater than and equals to sign. Means that vitamin 1 in foodstuff 1 and 2 should be equals to or more than 1. In the same way, it is 100x, this is 100x, plus 10y, this is greater than equals to 50, because here the word minimum daily requirement is given. So 10 for x and 100 for y. This is equals to and greater than 10. So these are my three subject to constraints, but we can write whereas x and y should be greater than equals to 0, means being the non-negative values, being non-negative. Okay, so this way I will formulate the linear programming problem. Now rest is up to the question that how we have to solve this, whether with the help of graphic method or with the help of simplex method, that we will cover in our next sessions. Now let's take one more example to clarify the concept further. In this question, it is given that a company produces three products, X, Y and Z. So you can see here in this question table is already given. A matrix is already formed. Okay. So this is the matrix. So three products are given X, Y and Z. Fine. And the profits are 3, 2 and 4. So we can write here that profits are 3, 2 and 4 for three products, for X, for Y and for Z. So again the profit concept is given. So the case is of maximization. Maximization, right? The company has two machines. Now two machines are given, machine A and machine B, and the processing time is given also, that a product X will take 4 minutes on machine A, Y needs 3 machine minutes on A and Z needs 5, while X take 2 machine minutes on B, 2 Y take 2 for B and Z take 4 for B, right? So this is given to us. Now moving toward the question, formulating the equations for these from this table, we write maximize Z is equals to 3x plus 2y plus 4z, because question is of profit. But this is attained subject to constraints. Now what are those constraints? That is 4x plus 3y plus 5z, and another is 2x plus 2y plus 4z. Now what are the total machine hours available, machine minutes available? So you can see here that machine A and B have 2000 and 2500 machine minutes. What does this mean? That machine A we have 2000 machine minutes, means that machine A is used for this much time period. It can be less than or equals to, but it cannot be more. So again this is a case of maximum machine minutes, and in machine B again it is a case of maximum, that is 2500. So machine B also we use it for less than or equals to 2500. Now the next line which is given in the question, that company must produce 1000x. Company must produce 1000x means that 1000 units are produced by the company. So we can write here as x must produce, means that we have to produce minimum of this, it can be more than this. So this is greater than equals to 1000. This is not 1000, this is 100. There is typing error. So x1 should be greater than equals to 100 because it is must produce. So this 100 is the minimum limit which is produced by the firm for x unit. And 2000 y, again this is must, again for y means y is greater than equals to 200 because must produce 200 units. So y also, the production of y product is equals to or more than 200 units. But you can see here that, and 50z, so z is greater than equals to 50. These are the minimum limits for x, y, z. But here it is given that not more than 150x, means that the maximum production in case of x unit is 150 units. So in that case, what we will write, that x should be less than 150, means the production of x unit should not be more than 150. So these are the equations which we form, but we can also write that where x, y and z, they are greater than equals to 0, being non-negative values. Okay, so you can see here that how many equations are there. First is of maximization, second, third, fourth, fifth, sixth and seventh. Or instead of these two equations, you can also write x is greater than equals to 100 and less than equals to 150. You can also write in this way. Whatever is comfortable, you can write the equation. Either you can write this one equation or you can write these two equations. So this way you will able to formulate the linear programming equations. I hope the concept is clear to you. Thank you.